All right, so today we're gonna take what we have learned in the previous lessons to try to solve the polynomial equations. So basically what we've done prior to that, we were learning how to factor polynomial equations, either by doing long division, synthetic division, or factor by grouping, so all the different kinds of factoring, because we know that when it's in factored form, we can find the zeros. This is what we learned when we were in grade 11 and when we had quadratic and we had to factor to find the zeros. Similar with any kind of polynomial, so if you have degree 3, degree 4, or any higher than that, you need to factor to find your zeros. Now, we learned that we can factor by division, long division, or we can factor by synthetic division or by grouping in the previous lesson. Now we're going to look how to solve. So we're going to do a combination of these methods. Now, in the first question, they're asking you for part 1 to investigate and to use technology to graph the function f of x equal x to the power of 4 minus 13x squared plus 36. So we're going to use technology to graph this. So I am going to go to Desmos and to use technology, so y equals, and then we have x to the power of 4 minus 13x squared plus 36. Now before I go into this, we've already looked at the graph, but you should know that this graph is going to be opening upward. It's going to be from quadrant 2 to quadrant 1. You should know that this is also an even function, because if you remember that for an even function you need to have even exponent for every single term, and you could have a constant. So this is going to be symmetrical along the y-axis. So here's the graph. As you can imagine, and I have in this case 4 zeros, and this is one of the possibilities. How many zeros can you have? You can have 0, you can have 1, 2, 3, or 4. So in this case I have 4 zeros, and my zeros are -3, -2, 2, and 3. So let's copy this graph into there we go. It does look a little bit stretched, but this is the best I can do right now. So here's my graph. And then we said that the x-intercepts are -3, -2, 2, and 3. All right, now the question here is asking us in part C, factor f of x, then use the factors to determine the zeros of f of x. So they're asking us to factor. So we can factor here using long division, or we can factor using synthetic division. But also I'm going to show you a different way also here to factor. And the reason I can do that is because I have x to the power of 4, x squared, and a constant. I can do that. So I can factor it like a quadratic, okay? If you don't know how to do this method, just use the regular long method, okay? So f of x equals, so I have x4 minus 13x squared plus 36. So what I can do is I can write this as x squared minus 13x squared plus 36. So if I'm looking at this, I see that I'm looking for two numbers that multiply to 36 and add to -13. So two numbers, the product is 36 and the sum is -13. And that's going to be -9 and -4, right? So negative 9 times negative 4, that gives me 36, and that adds to negative 13. So that means I can do, I can factor this as x squared minus 9 and x squared minus 4. And as you can see here, this here is my, let's do this. So I can say let a equals x squared, right? And then you will have basically a squared, because I'm replacing x squared with an a. So I'm replacing this x squared with an a. So it will be a squared, and then minus, and then I'm replacing this x squared with an a. So that's going to be 13a, and then plus 36. Right? So you see that now this is a quadratic structure, and I'm going to have a minus 9 and a minus 4, right? And then now a is x squared minus 9 and then x squared minus 4, for those of you who like to see what happened here. So basically I'm replacing the x squared. I can do it like that, okay? Just so you know what's happening. Now, if I'm looking at x squared minus 9 and x squared minus 4, what I have here is difference of squares. So I have x minus 3, x plus 3, x minus 2, x plus 2, because that's a difference of squares, right? And now, as you can see, this is all factored. And then to find the zeros, I'm going to set each bracket equal to 0, and I'm going to find all the zeros. So that's going to be x equals 3, x equals negative 3, x equals 2, and x equals negative 2. So this is one way. If you can see this, if you can see that this is actually can be written like this, you can do it, or you can do like long division or synthetic division. So how are the x-intercepts from a graph relates to the roots or the zero of the equation? The zeros of the equation are the x-intercepts, right? So the zeros of the equation are the x-intercept of the graph of the function. All right. So the next question is asking us to state the solutions of the following polynomial function or polynomials that are already in factored form. So this is already in factored form. They want you to find the solution. It's set to equal to 0, right? If it's set equal to 0, to find the solution, you're going to set each bracket equal to 0. So you're going to say x is equal to 0. You're going to set 2x plus 3 equal to 0, which means 2x equals negative 3, which means x equals negative 3 over 2. And then we also have x minus 5 equals 0, which means x equals 5. So these are the three solutions for this factored form. To find the solution for this one, I have to make it equal to 0. Because anytime you're finding the solution, you want one of the sides to equal to 0. So that means you're going to set 2x squared minus 3 equal to 0. So I'm going to bring the 3 over, so that's 2x squared equals 3. And then divide by 2. And in this case, you're going to have to square root, but you have to be careful that when you square root, you're taking the plus or minus square root. Because both answers, the plus or minus square root of 3 over 2, if I square them, they would give me 3 over 2. So in this case, I have two answers, plus or minus square root of 3 over 2. Then I'm going to have to set this one equal to 0, so I have 3x squared plus 1. And that's going to give me equals 0, so 3x squared equals to negative 1. If I divide by 3, x squared equals to negative 1 over 3. If I take the square root here, it's going to be x squared equals plus or minus square root of negative 1 over 3. And this is not a real solution. Because I can't have it's an imaginary number if I have a square root under the negative, right? A negative under the square root, sorry. So this will not give me a real zero. So when I'm graphing this function, I'm gonna have two zeros. I'm gonna see two x-intercepts, and they're gonna be a plus and minus square root of 3/2. You can try that on Desmos, and then make sure that you get the same answer. So how can we factor? Because we know that we need it to be in factored form in order for us to find the zeros. So we can do long division and synthetic division. We can do factor by grouping, difference of squares, common factoring, sum and product, sum and difference of cubes. So all of these are methods that we should know for factoring. It depends on what I have, then I'm going to have to follow whichever method is appropriate, the appropriate method. So here's the question. Solve each polynomial equation by factoring. So I'm going to look at my, my polynomial. I have x cubed minus x squared minus 2x equals 0. Always, no matter what scenario you always have to ask yourself the first question, which is, do I have a common factor? That's always should be your first question. In this case, I do. I have a common factor of x. So if I factor x, then I'll be left with x squared minus x minus 2 equals 0. So you see here, nice, I have a quadratic. So with quadratic, I'm looking at sum and product. With a polynomial, trinomial, quadratic, I'm looking at sum and product. So I'm looking for two numbers that multiply to -2 and add to, so let me just write this, common factor. Then I'm looking for product of -2 and sum of -1. So what multiplies to -2 and add to -1? -2 and 1. So then I can factor as x minus 2, x plus 1. So what I did here, I did sum and product. Now, as you can see, this is totally factored. So what I can do right now is I can set each bracket equal to 0 and find my solutions. So what I have here is x equals 0, x equals 2, and x equals -1. So my solutions are 0, 0, 2 and 0, and -1, 0. All right, so that was not bad. Let's look at the second one. So I have 3x cubed plus x squared minus 12x minus 4 equals 0, and I'm looking to factor. So the first thing you want to look at when you have 4 terms, you probably want to look to see if you can do common factoring. First of all, do I have any common factor? No. All right, now let's see if we can, because we have 4 terms, sorry, we need to look at factor by grouping. So if I'm looking at factor by grouping, sometimes it works, sometimes it doesn't. So factor by grouping, you're going to take the first 2 terms and then you're going to try to factor something out. You're going to take the second 2 terms and then you're going to try to factor the common out. So to factor the common out of the first 2 terms, I have x squared. So I'll have x squared and then I'll have 3x plus 1 left. From the second 2 terms, I can factor a -4 out. So I'll have 3x plus 1 left. Beautiful. So how do you know it works? If you're factored here, if you have a common factor here. So this here, I have a common factor. So that means that works. So I don't have to go through the long division to factor this. So what I have here, I did factor by grouping first. Now what I'm going to do is I'm going to look if I can factor any more. And as you can see here, I can factor a difference of squares. So I have 3x plus 1, and then x minus 2, x plus 2 equals 0. So what I did here is I did difference of squares. Now, my zeros are going to be, so set each bracket equal to 0. So x equals 2, x equals negative 2. This needs a little bit more work, so that's going to be x equals negative 1 over 3. Set it equal to 0 and isolate for x if you don't know how I did that. All right. Now, as you can see, my solutions are going to be negative 1 over 3, 0, negative 2, 0, and 2, 0. All right. All right. Now, use the factor theorem to solve f of x. So they're specific here. They want us to use the factor theorem to solve for f of x equals 2x cubed plus 3x squared minus 11x minus 6. So because I have an a value of 2 and the value here, so because my a value is not 1, I'm gonna have to find the factors of a, find the factors of the negative 6, and I have to do b over a. So remember this. So possible values for b or factors for b, that will be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So these are the factors of 6. Now I'm looking for the factors of 2. That will be plus or minus 1, plus or minus 2. So the possible values of b over a, so you're going to have to take the values of b divided by a. So I'll have plus or minus 1, plus or minus 1 over 2. If I take if I take 2 and divide it by 1, so that's plus or minus 2. And then if I take 2 and divide it by 2, that gives me 1, so I'm not going to write that. Plus or minus 3 divided by 1, so that's plus or minus 3. And then plus or minus 3 divided by 2, that's plus or minus 3 over 2. Then I have plus or minus 6. And I have plus or minus 6 divided by 2, that gives me 3. I don't need to write that. So these are the different possible values. We're going to have to try to plug in all the different, or I would personally start with the whole numbers, start with a 1, and then move on to the fraction if I need to. I'm going to try, because I know what it is, I'm going to try f at 2. If I plug in 2, so let's see, 2 to the power of 3 plus 3, 2 to the power of 2 minus 11 times 2 minus 6. So that's going to be 8 times 2, that will be 16 plus 12 minus 22 minus 6. So that's going to give me 28 minus 28, so that's going to be a 0. So now I know that 2 is a factor, and then x minus 2 is a factor. Now, now I know that what my factor is. Now I'm going to do synthetic division to factor, because synthetic division is doable in this case and it's easier. All right, so let's set it up. So it's going to be 2, 3, minus 11, and minus 6. My factor is going to be 2. Bring the 2 down here. Multiply 2 times 2, that's 4. So that goes here. Add 7. 7 times 2 is 14. Add, and that's going to give me 3. 3 times 2 is 6. Negative 6 plus 6 is 0. So that's going to be my x squared, my x, and my number. All right, so far this is what I have. I have f of x is equal to x minus 2, and then 2x squared plus 7x plus 3. Now, I have quadratic, So the quadratic, I need to do sum and product, but because it's a decomposition here, because a is not equal to 1. So I'm looking for two numbers that multiply to, so the product is 6 and the sum is 7. And that's an easy to be 6 and 1. So because the a is not equal to 1, I have to do decomposition. So that's going to be 2x squared plus 6x plus 1x plus 3. I assume that you guys know what decomposition is. If you don't, come and ask me. So that's going to be common factoring of 2x. And then I have x plus 3 left, common factoring of 1. And I have x plus 3 left. So that's going to be x minus 2, 2x plus 1, and then x plus 3. And my zeros are going to be 2, negative 1 over 2, and negative 3. All right, so that would be 2, 0, negative 1 half and 0, and 3, negative 3, 0. So these are all the different zeros. So what do these answers represent? So this represents the roots of the equation, okay, which means they are the x-intercept of the graph of the function. So they represent, let me see if I can type that. It's easier than writing sometimes. So the values of x equals negative 1/2, negative 3, and 2 are the roots of the equation, which means they are the x-intercept of the graph of the function of x. All right. So here's another example. Find the zeros of the polynomial function f of x equals x to the power of 4 minus 2x cubed minus 7x squared plus 8x plus 12. And in this case, your a value is 1. So you're only finding the factors of 12, okay? And then you're gonna do the long division or the synthetic division to find the different factors, okay? So the factors are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and I forgot the plus or minus 4, and plus or minus 12. Start with the lowest numbers. I'm going to start with f at negative 1. It's going to take you some time to figure them out, but that's fine. So it's going to be negative 1 to the power of 4 minus 2, negative 1 to the power of 3 minus 7 times negative 1 squared plus 8 times negative 1 plus 12. So if I do the math here, I am going to end up with 0. So x plus 1 is a factor. All right, in order for me to factor this, I'm going to use synthetic division. Again, in this case, because we are dealing with x plus 1, which is basically degree 1. It's linear. I can do that. I have 1. I have negative 2, negative 7, plus 8, and 12. And then my factor here is negative 1. Bring down the 1, I'm multiplying, so 1 times -1, that's -1. Add, that's -3. -3 times -1, that's 3. Add, that's -4. -4 times -1, that is 4. 8 plus 4 is 12. 12 times -1 is -12. I'm adding, that gives me a remainder of 0. So this is going to be x cubed, x squared, x, and the number. So now what I have the following. So I have x minus 1, and I have x cubed minus 3x squared minus 4x plus 12, and then equal to 0. Now, in this case right here, I have 4 terms. So because I have 4 terms, I'm going to try to see if I can do factor by grouping. If I look at this factor by grouping, I'm going to factor x squared. So that's going to be x minus 3. Factor -4. That's going to be x minus 3. That works. All right. So because this, I have a common factor, that works. So that's going to be x minus 1, x minus 3, and then x squared minus 4. And then I have to see if I can, I have to factor this quadratic, and that's difference of squares. So it's going to be x minus 1, x minus 3, x, x plus 2, and then x minus 2. So you see that my zeros are going to be 1, 3, -2, and 2. All right, so you can write the solutions here. So it's going to be 1, 0, 3, 0, -2, 0, and 2, 0. All right. So what I'm going to do for the other questions is I'm going to write the solution, and I'm going to write the solution down, and if I have any more questions that I want to put on the video, I will put it on another video, just because this is becoming a bit too long.